APTLD. Uh, this panel is invited some ICANN staff, some IETF participants, and I, on behalf of Yeti project, I participate in this panel to contribute some comments and values. In the beginning, Davey right now is the board of ICANN on behalf of ASEC corpus, ASEC, I think. I type right now. He worked for the RIPE NCC. He asked a question in the beginning, are we considering different reason or still talking about a single reason but distributed alternative method? So we discuss existing alternatives. There are two categories. One is namespace in different technology. Sure, different technologies set up different ecosystems and different namespace. There are, for example, handle system for DOI usage. You may know your paper are published with the DOI secret, DOI label, so that's used for that purpose. Namecoin for Bitcoin. DNS for Ethereum. IPNS for the IPFS. That's all based on some kind of chain, distributed ledger technology, and they also list alternate. You can track the dictionary for the definition of alternate. It's basically the same technology of DNS used, but so a total different namespace. They register the new, appending the current existing namespace at far end. So there are namespaces in different technologies. And there are other categories of distribution mechanisms. Yeti is one of them. I think Paul in the morning also mentioned the position of Yeti as a signer and signing position, and also the distribution position. And obviously 7706 is kind of alternative distribution mechanism. So in the beginning, we discussed what's the problem space, what we are talking about, right? The difference. Okay, next slide. Different politics and motivations may target different authorities or different functions. So they are major. I just categorize them to make a binary to them, not mix them up to cause confusions. So activities may different in authority from different level. I think Paul's slides already introduced these three layers, and I think we think alike that there are different alternatives on the authority of namespace at the registry. So different registry will register different namespace and different names actually. And the authority of signing, so different authorities can sign, use their own way, have authority of signing, different authority. And the authority of distribution, so that different layer and the match to the problem you want to resolve. So, and the different authorities also has different motivation and problem statement. Some may care about data privacy or the stability of their infrastructure to keep autonomy of network, different regions and different countries. It's fair. And one motivation may just remove bureaucracy for technical simplicities. Right now, I can act like a governance entity to run the namespace. It's become more bureaucracies, so people may come up with new namespace, new technologies to remove that cost. And there are other motivations, like to avoid single point of failure by adding redundancy, more tolerant. Well, you can see this promising motivation match for the mostly the distribution part, and also signing part. Different motivation target different problems. Makes sense. Okay, I do some research and I categorize it and then analyze the pro and con of each. I noticed that this is the pointer given by Paul, because I see I was interested in this field, and he gave me some reference, some pointers to this presentation. This presentation is given in the year of 2003, and John Herman, I'm not sure how to pronounce this. John Herman. Johan. We call you. Okay, I just call him John. Okay, John introduced a kind of DNSSEC management of KSP, case signing key. He gave a presentation to write 45. Next. And the simple slide to introduce this proposal is that we want to introduce multiple authenticators. We can just call it multiple KSK or multiple transaction, because in his proposals, the category is different roles functions. There are some cases are for operational purpose, some cases are for authentication purpose. So his proposal is to introduce multiple trusting KSK. So his proposal is simply in one sentence: increase the trust in the operational keys by introducing multiple independent authenticators. It's exactly similar with the design of our multiple KSK and the multiple GSK model. He introduced more than 10 years ago. Next slide. Okay, there are some consequences in the entity. With multiple authenticators or trust enters issued by different entities, we get a larger aggregate trust base. I put it similar like the web of trust. It's like each Internet Explorer, it can build a trust, a group of CA as a trust base. It's a kind of web of trust. Same differential of the trust by different subsets. Yeah, it has an assumption that different subset of reservoir population, different reservoir population have particular one or more than one trust network. Like the web trust, your Chrome can install more than one CA, right? Entity for the purpose of SSL certification, and the possibility of more robust rollovers, since not all trust keys will roll at the same time. That's will help you for the rollover case. For example, if one fails, another trust enter and another trust can stay alive. The option of using local policy keys and different security needs. There are other slides to introduce. Next slide. One example is that one local policy maybe I require valid signature, but at least one for following 5 authenticators. So that's the logic of or, not and. If only one of them can validate the signature, then the resolver will accept the answer. That will improve the robustity during the rollover. And there are also some threshold validation idea. I require valid signature by at least 3 of the following 5 authenticators. So that's the model. Very that's like the property we like to pursue, but it's the implementation different. This would improve security, but dramatically less the consequence of a single key compromise, because in a distributed network, the unique authority can be compromised by hacker or some behavior, misconfiguration. So that will increase the probability of that as well. And he also proposed a draft proposed in 2004. I just go through the threshold validation and grab the main idea from the abstract next slide. This draft introduced a different model of validation, aware reservers. So he defined a validation, a new type of DNSSEC, aware reservers. The key change is that we change the model of one key at a time to multiple keys. So the basic idea is that he trusts multiple trusted chain, not a unique one. Yeah, there's some benefits. So I already introduced in the example 1 and 2. Next slide. This idea is repeated, proposed in the IGP proposal drafted by Brendan Boomer and Milton Mueller. This is we can call it famous guy in this field or not.
It's rather highly controversial.
Very controversial, yes. And he also proposed one proposal, security rules, proposal distributions, signing authority in IGP. I read this draft. It's generally the same with John's. He introduced multiple trust anchor. This proposal called it root trust operator. So it can bring some properties. If one fails, another stay alive. So the validation process rely not on one C but also other Cs. It's basically the invitation of web trust into DNS trust. Okay. Next slide. Okay, some concerns. I also collected some discussion around this really work. It requires the modification result to accept the multiple trust engine. So that may very difficult to implement in the current installation DNS system. Another concern is the large packet size with more set of keys. Those keys can exist because in order to achieve the property proposed by the John and Mueller, they need to include all the trust anchor key, case key, and all the disk key into the packet. You can calculate. You will double or triple or 4 times of that if you introduce more than one. That's the big concern. Even some discussion brought into the DNS or people trying to use TCP to carry that large, but it's not accepted at that time in the early 2000s, 2009, 2003 or 7. Okay, so I'm thinking that we do want to introduce more redundancy to the root system. Has a fault tolerant property in signing distribution. So we only target signing distribution, not the registry function. So I asked 2 questions here. Can we introduce multiple independent signatures without changing the user validation interface? Because in the previous proposal, it requires reserver to add some function into the reserver to aware that there are several parallel trust chain, right? This need modification in the reserver. So we need some mechanism or some approach without changing that. Can we do it without augment the size of DNS response? So that's also to respond to the concerns I just raised, because the previous work by adding more keys into the response. So it's not quite acceptable in the background of basic fragmentation. Okay, that's the requirement and the questions in my mind. And after some discussion, there is a thought and quoted here. Think about DNSSEC in the background of classic Byzantine fault tolerant context, in which we may borrow some ideas and ways to distribute ledger, blockchain, or whatever. Okay, I just do some search, keep some search and in depth. I try threshold as a keyword, signing or signature as a keyword. So I do grab some news and some technology reports. There are some just to get provide a short update. The title is the threshold size signature. The news standard for war. It's good. It's a Bitcoin magazine. Basic idea for threshold or multiple signatures for wallet, because in Bitcoin there is a risk that if one guy has asset a lot of Bitcoins, use a wallet to do every transactions. What happens? What if the wallet is compromised? If they lost their keys, or if their machine is just broken and cannot save the key, secret keys. So if the wallet is only one, that wallet became the single point of failure. So threshold signing serve this purpose to provide multiple signature or multiple secret to support multiple wallets. So if one or few of the wallets are stolen or compromised or destroyed or failed in many possibilities, it still survived by most of them alive wallets or signatures. So that's the basic idea. And there are also some discussions on ECDSA, threshold signing. That's also the keyword, buzzword attract my attention. Okay, and there are also some technical description of the property threshold signing as a significant milestone. Instead of using multiple signature, we observe that joint control can be accomplished using threshold signature. In a threshold signing scheme, the ability to construct a signature is distributed among n participants or players, each of whom receive a share of the private signing key. That's the description of the capacity that can share one signature into several parts of private shares. Next slide. And there are also there are two layers. I don't define the okay. Actually, they're similar to describe some technical law to describe the threshold sign signatures and related approach. It's introduced a concept. I just learned the concept of aggregate property of keys and signatures. It helps me to understand there is a property that can generate keys into several or more than one. We can put it for n part of secret shares, and signatures can also can be signed independently, and then we can aggregate them into one key and one signature to fit the current the public key infrastructure. Next slide. Okay, there is a vivid example I just quoted from the blog. How DNSSEC signing works. That's how right now the unique trust signing. Alice is the signers. They sign a message to Bob, and the private key is only visible to Alice. And the public key is visible to everyone to validate this signature. So that's how DNSSEC actually do. The DNSSEC signing works. Next slide. Okay. There are also examples to describe how previous threshold validation works, like John and Newton proposed that there may be several persons. Each person sign one message, and it's job's obligation to validate each and decide by himself about the threshold value. So it's a bit complicated because he needs to know each one's public key, and he needs to receive each signature from number n people. That's the cause, that's the reason the response will be nudged, and people cannot bear that argument. Next slide. So the desirable threshold signing works is that each of them make a signature for the same message. You notice that it's the same message, same piece of message. Message will aggregate it to one. This one is the unique signature for this message, but it's generated by group of signers. So that's possible that the Bob can just use in the previous scenario that it can treat them as a one person, one group of person, virtual person to sign a message to him, because there is an aggregatable public key available for him to validate this aggregated signature. So that's actually diagram is desirable for what we going to define for the signing, multiple signing or threshold signing for root. For example, the message can be the root zone record. You can put it as a DNSSEC key record or just the other resource record. And there are plenty of them, more than one, more than three, maybe 10 or maybe 100. They can sign the root zone or DNS key record, use their private key. And finally, it will generate a unique signature, unique root zone, just look like the theme of the current system has. So it keeps the interface of user unchanged. The user can validate this joint work of signing just as one person to sign this the root zone. Okay, that's focused on the signing part. Then we can break down the signing responsibility into among a group of signers. There is another question. Because in this diagram, everyone has consensus on the root zone, right? They have the exact message to decide. That depends on the message we want to send to Bob. If any of them have different message sent to Bob, that will not work. They have assumption that they already have achieved consensus on the root zone. So that's maybe another question, more upper side for the registry part. What's the namespace look like? Or what the namespace exactly registry in the root zone. So the signing, the aggregate or threshold signing, not deal with that problem, not deal with the registry or namespace definition problem. That this diagram only deal with the signing process to get rid of the central role and provide the redundancy. Non-redundancy is provided, how to say, to add more people here. Yeah. Next slide. Our redundancy. I refer to that. Okay. So that's a problem. That's an issue. That's a question we need to ask ourselves. Which layer should we focus? On the sorted namespace or on the signing and distribution? If we have some approach to sign the root zone, just as we described in previous diagram, we can achieve this purpose, so that we can generate a pair of keys at trust anchor side each report on the work among distributed entities. But this part is not in the current scope of the requirement. Next slide. But possibly we may propose future work on Yeti testbed to bring fault tolerant DNSSEC just as the threshold signature threshold signing does for Ruzo with M of N threshold signing. I think we can first achieve this at the first step, and to see whether we need to go further. That is the root zone generation based on consensus in case of thinking about ICANN and a function. That's maybe the next step, or maybe not maybe the third one we're not going to touch, but at least we can achieve this at the first step. Okay. Next slide. Okay. We'll stop here. That's the slides I prepared and all my thoughts when I do some study and research on this. I think if we can achieve this at first step, at least we can answer the question who to be the DM role in Yeti next step. Everyone can be if you want to participate, especially in the context of ICANN. We can propose if this approach mature enough, ICANN can ask all their TLDs, TCP TLD and GTLD operators to participate in the signing process. Okay. That's all. Any questions? Or suggestions? I noticed some guy entered the virtual meeting, right? It's not Hugo? Okay. We have not have Hugo right now.
So Davey, so what are the calculation to get the aggregated key from the out of the distributed keys?
As far as I know, from some technical blog and some paper, I just didn't get to read some of them. We have a key generation process that there is a winner in the beginning initialized to publish the secret, partial secret to group of signers. Then, so their keys are connected in some mathematical ways, and they sign differently, and each of them generates a signature of that copy of the record that you want to sign, right? And you can aggregate the signature into one again. So you distribute many, and many then aggregate to one, and as an input to the current DNSSEC. That's the basic idea. But right now, I need to talk to some people very familiar with this, and some tours with this. I think it's already another new work in the crypto field. So I just found the requirement and potentials and picture some landscape for the future signing for Ruzo.
But each of the key doesn't have to be independent, because in to allow that particular functionality, the key need to be mutually related or mathematically related together.
Yeah. Right. They cannot generate their key by themselves.
So key generation process is not distributed evenly.
Yeah, yes, you are true. If that process is just rare to change, I mean, just like PSK,
Right.
it's just kick off the system, launch the system, and the system can run for quite a while. No involvement. Maybe some ceremony needs as well. But I also read some paper says that centralized dinner is not necessary in some case with some mechanism. But I'm not use that. I'm not implement that. I'm not sure right now. But the potential is that there's some way of to get rid of the central role dinner by some distributed way to generate the key shares. I need to say that this is different from blockchain. Blockchain, each participant has their authority on their data, their asset, right? So they have their own key. They don't necessarily to split among multiple. Maybe some kind of application scenario like contract or some, they need some group signing. But basically, the blockchain itself don't necessarily need multiple signing. It's an enhanced security, as I present some news talking about multiple signature for wallets. That's the enhanced security consideration.
The other question I have is that the algorithm is totally different from the traditional one that used in the current DNSSEC model.
You mean different algorithm for insect? For special signing, as far as I know, read some. They are different type of special signing for RSA or ECDSA. I think it's compatible. It's compatible with the existing algorithm from the user's point of view. I see. The process is the same, but the algorithm is different. It generates smaller signatures, smaller key. But I need to admit that right now we are just doing some research to analyze the requirements and potential. And next, if we think it's worth doing, and we will to implement, to try some ways, or some ways to implement in lab tests, for example, and to see whether the current algorithm like RSA or ECDS is already mature to fit the threshold signing scenario. So
You mean that if we may able to forget about the packet size limitation or something like that, any algorithm can be combined into the aggregate key signing.
If we get rid of the limits of the packet size, the previous proposal.
Okay, forget about the packet size.
Okay, forget about that.
Yeah. And what users need to know is the aggregated key.
I think users are not necessary to know how the zone are generated inside. They only need to know which is the public key, just as the DNSSEC does. The zone generation process is different from the DNSSEC validation process, right? You can generate the zone in different approach.
Can you go back to this slide of the one more? Yeah, this one. So what we both need to know is the aggregated key.
Yeah.
Aggregator or public key, more precisely.
Yeah.
And there are different messages, right? right? Same messages with different signs, right?
Yeah, yeah. Different people use their share of secret to sign the message.
Okay.
This message is different.
Okay, so in order to verify the message, then both need to know the sigma and also some of the signatures. The number of the signatures he needs will be more than one.
You know, from Bob's perspective, he didn't know there are many of their signs. He only received one signature. This signature can aggregate or combine, generate by a function to a unique signature, just as the DNSSEC signer does to generate one signature. That's different from the previous slides. Some sign. You know, if there are no other no special deciding, each one sends a message and a signature, and Bob needs to verify each of them and count how many validate a valid message. Then he will decide to accept this message or not.
Yeah, that is much more intuitive.
Yeah, that's the intuitive thing.
But I still do not understand the next.
Okay. This is the easy to understand, right? This will increase every signature and every key in Bob's response. Yeah. So that's the argument of this response. Next slide. Next slide is that Bob only asked, just like we did to dig a DNS key or with a DNS stack, we get a signature and we call. We will sign it, we will validate it locally, right? And it will validate, just as the normal DNS validating result do. But behind that, before they validate, the signature are generated in a different kind of signing mechanism that require the technology to firstly distribute the secret share to different identities. So each of them use the secret share to sign this message, and then they will. I suppose there is a kind of centralized entity or uncentralized entity to publish this unique signature to Bob. It depends on how the information and the signature are distributed among the servers or socket servers.
So in this case, if this particular technique is applied to the DNS zone, then I think every person, one person, two person, three, are not able to sign the zone by themselves.
Why? They can pull from Diana and use their secret key to sign. Actually, right now there are no distinguished KS key and TS key, right? We just imagine they have a key to sign.
Okay. Yeah. Okay.
I also mentioned that content needs to be unique. This process needs some standard for each of them. For example, we have 3DN, right? Person 1, person 2, person 3 as the 3DN. Right now, we pull the zone. We pull the zone from Diana, pull the zone from the root server. We may also ask directly to each TTLD or TLD, ask for their metadata for the root zone to compose the root zone independently. That basically guarantee the content.
No. My question is, given a record, any record, there is more than one person signs the record.
Yeah.
Right.
Yeah.
And
but these signatures are not published in DNS. Not yet. That's the intermediate signature.
And then the signature need to be combined together.
Yeah.
So that
before DNS.
So that portion could be a single point of failure. Am I right?
Yes. If you if you specify one row here to connect all the partial signature and do the function, unique function to combine and aggregate, you are true. But this function can be done independently if the network are connected, or maybe one of them, and they can broadcast the message and the signature to each of them. So each of the person can receive all the signatures and the messages, and they can combine by themselves in one algorithm, unique algorithm agreed by all of them. And just like a P2P network, everyone has a copy of all the messages and the signature, and they can generate it independently and without synchronized. And that's the part that is missing about the underlayer network. Underlayer network, the support is there's some hash table network to distribute all these messages, and then why Bitcoin can how to say it, can anti some attack, because Bitcoin, everyone has a copy and allows their copy, and even only the longest thread has consensus on the right data is the longest one. So then the longest one will adopt in the interface of DNSSEC, for example, the user interface. But that one is missing. Please, I admit that. We can define a dinner in the first step, a dinner here and dinner here to distribute and connect it.
Maybe I think the Bob and collect the signature and group it together in some way. And
yes, but Bob, that means Bob is intensively participates to this network. I have an assumption that Bob stands for the legacy part of DNS. I mean, unchanged DNS reservoir parts and publication parts. One possibility is that Bob asks questions from authority servers or reservers, right? Authority server and the reservers on the record, on the domain, specific domain, can join the network of this part to combine messages. It's to be defined.
But I'm not sure whether the verification process is the same with the existing verification.
Oh, yeah, that's the property given by that's property of special validating. I'm not to prove it to you. I just introduce that there's a approach, that's a mechanism to has property of aggregatable public key and aggregatable signature. That's the property, and that public key and signature has the same nature of ISA or CD, ECDSA. We need to test it. If we have some tools or some, we need to document it. Hugo proposed they have already implemented something, so I'm very keen to invite him to join our discussion. So, okay, we can discuss later and use the whiteboard. Okay. Hugo is not here. This here. Okay. Okay, that's mine. How about Jackie? How about your presentation?
Have you reached out to Johan?
I send mails. No response.
Uh, 哎，没有考过来。嗯，等会儿那就行吧，这个办。什么标题啊 ？distribute 啊，这个看到了。这个，稍等一下，我先把它调好了。你稍等一下我。完了。然后分享屏幕。哎，不是。把它选出来。Okay, let's go.
Hello everyone, I'm Xinpeng from Network Economic Lab from Hugo, and I'm here to give a brief introduction about a project named Decentralized Internet Infrastructure in our lab. Next slide. We focus on the infrastructure of the internet. It includes, for example, the BGP, DNS, and PKI, things like that. There are some examples. For BGP, it's very critical to the connectivity of the internet, and there are some designs like RPKI for the security of the BGP system. And for DNS, you are a DNS expert, and there is a DNSSEC that provides trustworthy of the name ownership. And PKI is widely used in today's internet for the end-to-end communication. Okay, next. Currently, the trust infrastructure are all centralized. They are all in the form of hierarchical centralized structure. And here is an example for the RPKI. The N is the root, trust root, and there are 5 IR around the world. And next below national NIR and ISP is centralized and hierarchical structure. The next. The problem about the centralized structure. The first one is there a single point of failure issues because the system all rely on the central authority as the trust anchor, and the anchor has very high ability to control the whole system. Once the authority is hacked or compromised or misbehaved, the result will be might be a disaster. And there are also some risks that an authority in one country also damage the trust anchor of organization in another country because they are all chained together. Okay, next slide. Here we give some example about real world instance. The RPKI. RPKI is used for the security of security, and it can provide perfect hijacking. But there have been several instances around the world that the shows that the RPKI system has its vulnerability and can introduce a security risk to the system, and DNS, also DNS is DNS case and the PKI some for the PKI some certificate or authority was cracked and make the internet very vulnerable. Thanks. So we think that the internet is decentralized trust infrastructure. The decentralization is the dream of the internet, and we think every person, organization, and country should be equal on the internet, and no one have higher privilege of others. So the decentralization of trust infrastructure is to build trust and equity of the internet, and further facilitate the healthy and long-term sustainable growth on the internet. So I think it's very important for the internet to grow in a security way. Here is an overview of our structure, of our architecture. Maybe 3 layers. The bottom is the distributed ledger layer. We use the distributed ledger to provide the support of the decentralized characteristics, and we can run consensus protocol and smart contract to business logic or some technical logic. And in the middle layer is mainly the namespace management layer. In this layer, the internet resource, number resource, the ownership of the internet name resource will be provided. The number resource mainly includes the IP address, autonomous system number, domain name, and some other host identity, for example, LT ID. And the up layer is the application layer. The application here use the service provided by the management layer to do some decentralized trusted application. And we will give some example about the application layer service. Next slide. The distributed ledger is a brief introduction. The left one is the current decentralized architecture, and here is the decentralized architecture. In the decentralized architecture, the peer-to-peer, there will be many different entities act as the peer, and they connect together to reach consensus by the specific consensus protocol. And the data are managed in the distributed in a decentralized way. Each entity on the system will maintain a copy of the data, and the transparency of the data is provided. Okay, next slide. Yeah. Currently, we have finished some improvements on the blockchain for this trusted infrastructure. Our system is based on the permissioned ledger, not the public ledger, and we have finished some lightweight verification of the records in the blockchain. Okay, next slide. The namespace management layer. This layer is mainly for the ownership management of the namespace and the mapping between the name and for example, the name and the IP address, like that. Currently, we implement two kinds of ownership. The first one is IP prefix ownership, and the second one is the domain name ownership. In the ownership, the decentralized ownership proof, we say that no authority can unilaterally take down the custodian of an entity's namespace. So the ownership of the resource is not controlled by any single entity. And the trusted mapping is very important. The mapping between IP and the ASN which is used to improve BTP routing security, and the mapping between the main name to the IP address, which we to improve the DNS resolution security. Okay, next slide. Here we do a brief introduction about the management of IP. Our goals on as an IST or some brand, they independently own its resource, and the validity of the resource ownership and the mapping only depends on the owner itself, not depends on the third party. And we currently deal with the IPv6 address location because the space for the IPv6 is large enough, and there are almost no IPv4 address left. So we don't consider for the allocation of IPv4 address, but we consider the transfer from one entity to another entity of the IPv6. Okay, next slide.
I have a question here. You want to manage the IP. IPv4 is run out. The IPv6, there's still a large pool for allocation. So if you use if the IP management based on your infrastructure, who will decide who will allocate the IP for individual entities?
You mean, for example,
if I want to, if I on behalf of my company want to apply a block of IPv6/32 or something like that, how this happen? Can you make that?
In our initial design, every entity applies for the IP address by themselves. For example, if I want, because we think that IPv6 is very large.
Yeah.
And we control that by the payment for the IP address. Because when you apply for a block of IP address,
yeah,
you need to pay.
I know. I mean, who will decide the transaction will happen? There must be an authority on the address, right?
The end user, they don't participate in the consensus protocol. Yeah, they just send off the transaction and go. I want to
apply a block of address. Yeah. Who will
the consensus process will be finished between for example the IR or some need.
And it's not very clear that, for example, there is a pool of address. There are many of them will apply, right? And I'm not sure how the consensus works to determine which block assigned to.
The user needs to get permission. Because we design a permission for every entity will have an identity. And if we want to apply for the actual address, it will first be endorsed by some entity in the system. There will be endorser, role of endorser, endorse the transaction and other consensus nodes that made the consensus.
Okay. Okay, I will come up with other questions. Okay, next slide, right?
Yeah, here is use that IRSP. Yeah, they participate in the consensus process. And here is the consensus node, and the end user they just ask for just note the transaction, and the allocation of the address is finished automatically by the smart contract.
You know, I don't know, other people have other feelings, but I'm not very clear about how consensus and smart contract in this particular scenario. In your previous slides, this consensus smart contract is the key role, right? Key part. But it's not an almighty part, almighty function to resolve all the problems. Maybe if you have more details how it works, it may help. Right?
You mean how the consensus?
Yeah, how the consensus reached.
We in our first implementation we use Israel. In that case, the consensus is finished by the man, but that's cost a lot. And currently we focus on the Byzantine PBFT Byzantine cost tolerance protocol. Yeah, it runs in the form of a vault. Once there are most of the consensus node agreed about the transaction, the consensus will be finished.
Okay.
Currently, this solution it requires a lot of change to the current process, and currently we are working on a more of we can say is a revolution. We can't work on more revolution.
Next slide.
Yeah, next slide.
Okay.
This is for the mapping between IP and S. The mapping between IP and AS stands for the ownership of the IP address. Yeah, and the mapping will be used in the DTP system for the prevention of purpose hijacking. The ROA, the concept of ROA is borrowed from the Thunder architect system. It's verified that the IP prefix is announced by the right AIs. Okay, next slide. Here is the domain name. Because the mode of the domain name management is different from IP address, so it runs the domain name management runs in a separate smart contract, and the domain location is in a first come first serve manner, not using the sparse application algorithm like in the active place. And we we only focus on the SLE. We don't touch the .com or .net, something like that, and only focus on the SLE allocation. And there are the agencies such as Davey participating in the smart contract for the namespace operation, and the end user or the owner of the namespace, they apply, or for example, they apply for the, if they want to apply for a domain name, they will first ask the agency. For example, they transfer, they apply or transfer the domain name via the agency, because here we think that the user can't apply for the domain name totally by themselves. And for the CCTLD, the CCTLD is under the control of the NIC. Next slide. Here is an example how the SLD is applied. For example, if an application X want to apply the example.com, it will connect to the agency A or agency B, and the agency will generate the transaction for the domain name and the public key, and other nodes checks that the name is available, and it generates the results into the ledger. After that, there will be a record between the example.com and the public key X, binding them together. And if the applicant want to transfer the SLD, it almost always finished. They first connect to the agency, and the agency generates the transaction to change the ownership. For the CCTLD application, the participants are from the niche around the world. Yeah, and for example, the NIC generates a transaction for the dossier, and the other nodes will verify the signature and write into the ledger. Okay, next slide. The name for IP mapping. The contents maintained in the ledger is the main name is ownership and the authority server. We don't record all the DNS records in the ledger, because the records may change frequently, or there will be a lot of records. We only store the authority server information and the public key related to the domain name ledger, and the other records are stored off chain. Yeah, for example, in the server, authority server. And when the DNS client wants to query the domain name, it first connects to the distributed ledger, and it will return about authority server, and then it can connect to authority server to get the results.
Okay. So the cache reservoir is one node in the distributed ledger.
Yeah, it can get information or get data from the ledger, but it doesn't need to participate in the consensus progress.
So the cache reservoir got the strong message, or got the query and response, not from the. I'm not very sure about the cache reservoir behavior. DNS client send a query, DNS query, right?
Yeah.
To reach the cache reservoir. What next?
Yeah. First, this is the first one. The client responds the domain name, and the cache reservoir can get the information about the author from the trade.
So they don't need to reach root and then TLD and then second TLD to do the chain of that. It's just a flat. Okay. So who will tell cache reserver where the authoritative server is? Who will tell cache reserver about this information?
The cache reserver will connect the ledger.
So the ledger contains nearly everything.
That's true.
Yeah.
The ledger only contains this information is maintained in the ledger.
It's similar as the NS record, right? For domain, NS record is not a name server but a directory address assigned to it.
The signature, the public key and the public key.
Okay, I see. So it seems like that they hack the process of the resolution from reserver to authoritative server. The reserver not ask a root and other different layers of authoritative server. They directly ask the distributed ledger. The distributed ledger record all the domains and their authoritative server mapping. Okay.
Because the ownership about the domain name is recorded in the ledger.
So it's something like variation on root on resolve. Something like a root on resolve.
A root resolve.
In another form.
But with the whole domain names.
You know, in the beginning of DNS, people put all the records to one file. Before DNS concept was conceived. It's similar like this, but you use a distributed ledger. So the distributed ledger design is very important for this. DNS is proposed because the updates and the dynamic of the name changes are very high. So they need a tree hierarchy to, to distribute the node, distribute the authority into different domains so they can handle locally. That's the merit of DNS. Right now, you want to withdraw that delegation and to put all the the mappings as recorded into one system, flat system.
Currently, for example, for the Bitcoin, there are I think more than 100 gigabytes.
But the latency of the updates is a question.
Update, you mean update?
For example, there may be billions of domains, right?
Yeah,
billions of domains.
The more exact domain is maintained in the
this is the second domain, right? There may be millions of them, and each of them may be updated occasionally, and that will generate a high volume traffic of requests to update their mapping, right?
Yeah.
And for each domain, it's not a frequent operation, but there are billions of them. I once talked with Brian, mentioned about the updates issues, performance issues. If you put all the domain into one layer, need some kind of updating approach to handle. But it's not impossible. I mean, because in the early days of internet, their network, they have both like in the network, in the compute memory, in the computation, so they need to distribute and delegation the authorities to in a hierarchy step. But right now we have abundant network storage and computation. Yeah, maybe that some
for the distributed ledger, it can deal with thousands of transactions per
2,000 transactions per second is not very big number, not big enough. Okay. Do you have any idea of the updates of the domain, for example, .com? I have no idea. What's the changes or update per second for the domain under the .com? I know the root zone changes maybe 1 day per once. Hundreds, 1 or 2 hundreds a year. That's the changes of root zone. The root zone is very small. But large zones like
The number of delegation is around 1,000. But in the case of .com, I have no
they have
idea.
10 million.
10 million, yeah. That would be fair.
Yeah, we need some quantity.
I understand your
And I actually have last question. Does these resolvers, do they support the typical DNS resolution process? For example, if we have example code in this code on steroid file, on steroids, yeah. And I am as owner of, for example, code, delegated something like Dmitry example code to my colleague. So on my server 111, I which is, as I suppose, usual DNS server, right? I do run a usual DNS server, yeah, and I registered in this system, registered domain example code, which points to my authoritative server, which is completely usual DNS. Okay, and then I delegated subdomain, third level domain, to my colleague, to his completely now DNS server. These developers, do they support such a way of delegation? Yeah. So maybe I draw. Try to draw.
Okay.
So, as far as I understand, this cache is over. This in some kind also information about domain. For example, and I take my DNS server, which is somewhere here, 111. And I registered in this system domain example. Yeah. One. So information, this information, now this resolver knows about my domain. So, but this is ordinary DNS server, which runs bind or NSD or something. So, and I delegate third level domain to Dmitry, for example. Yeah, and I call it DM example.com, and it points to 222. So this resolver, can he resolve this domain? So can it follow usual chain of delegation?
Yeah, as far as I know, right?
Yeah, I think it will the cache resolver will resolve for the DM example.com for the
Is that?
Well, the cache reservoir only cache the example account, right? Not the D and example account, not right? Only in the second level.
Yeah, it can return the .com, it can return the record for the example.com, and then the process will go on to find the
So it can operate as a usual,
not recursively. I think.
but
不是递归查询嘛，你不会这个 cache reservoir 再去查这个 example account，
这开始之后就把一个单词放进去了，
传回来，然后呢，你还得往下查，就进去了。
它往外查还是往外查嘛？
It will be done by your start reservoir, right? Your client side. Not the cache.
Start resolver can do
Yeah, cannot do the recursive.
But this cache resolver from the system can do recursive lookup.
Yeah. Normally, the reservoir do recursion for the query until he got the final answers and return to the client. But in your design, your DNS client should do the recursion by themselves after he found the first example account. If you have many layers in the example account, for example, 1.1.1, and there are many delegation in this server, and your client first ask him to go this server, but you need to ask many times located final authoritative servers. So you put the hierarchy from here, you take character here. This server become the root server in your design. It can root server for this, for example, this DNS client become a kind of reservoir himself, right? If I make this. And also, maybe you're not a DNS guy, so there are many records, not only the A, called A, and also DNS and DSP and many things, many records. Not only in this one list, one entry.
In this situation, the only as record will be maintained.
I know you only want to find the authoritative server, right? Okay, we make it clear.
So
thank you for.
What is the answer?
What's the answer? The answer is that the DNS client server in this scenario will ask other
client works as recursive.
Yeah.
Okay. So this resolver, this system cannot exist alone with normal DNS domain.
I think cannot work with the current one. Yeah. You need to add additional function in the DNS client.
Dividing different from the register.
And also that's only in the diagram for resolution, not for the registry part, right? Okay, thanks. Next slide.
So following some application example based on the system. There is a decentralized web API because in the previous slide we have guessed the ownership of the domain name. So we can use the ownership of the domain name to provide passwords. There are different kinds of certificates in the DNS system. Domain or DV, and OV. DV means only the combination between the domain name and the public key. And the UV may contain some organization information. So in this example, because we have bind the domain name with the public key, so the record in the ledger can provide the functionality of the DV to the end user. The process here is about the process of the authentication. Okay, next slide. And another two applications. This one is the DDoS mitigation. Another one is the cross-domain end-to-end class provision. For the DDoS service, because in the ledger, the record between the IP address and ASN is recorded. And so if the victim was attacked by the DDoS traffic, it can get the source address of the DDoS traffic, and then by using the matching in the middle layer, it can find the source of the AS, and it can start a transaction to ask for the origin AS to provide the DDoS mitigation service. And another one is for the class provision. Is mainly for the VPN scenario. If the VPN is across several operator networks, and the end user can make a connection with different network to set up the VPN service and to form an end-to-end connection between the source and the destination. Okay. Vision. We want to build the internet with equity in the robustness, trust, and the innovation. Okay, I think that's all.
Okay. Any questions? I'm not quite familiar with API stuff. I think in this room, people are more familiar with DNS. Okay. So I discussed with BN several times, and he introduced this idea to me. At that time, I think that the first impression is that he wants to make the DNS hierarchy to a more flat. The impression is that the performance may be a consideration.
Yeah, right.
So my intuitive suggestion is you need to do some analyze on the performance quantitatively.
Yeah.
And also, as Peter point, okay, as Peter demonstrated that, you just make the flat for the root and TLD, but the hierarchy still exists in the second TLD, and the third and fourth and blah blah.
Yeah.
So your DNS client need to be modified to fit these situations. So that will be not even impossible, because you should have influence in the OS manufacturers like Windows and Mac use. So it's very hard. That's my
question is about consensus mechanism and how the organization can take part in it. For example, for DNS, we talked about network information centers that stands for country code, but there are also generic TLDs, and who will take the decision which organization can take part in this consensus TLDs, generic TLD entity.
We think that the formation of the system maybe the need, because there are not I think there are 7 or no more than 10 needs around.
You mean regional needs?
It's about
Five regional.
I'm talking about domains. So we are talking about CCTLDs and country. country code domains, but there are which your scheme is network information center that stands for this country code table. But there are also general purpose GTOD, and which organization are standing for these domains, and who delegate, which entity delegate the right to be owner for this particular domain, and how this entity took part in the consensus process.
The domain name, in this case, the user apply for the domain name by first server principle, and we think there's no entity control the specific domain.
For example, I want domain Dmitry, like Dmitry, top level domain Dmitry. What my steps are to gain this domain?
I think for the next slide. There are agencies.
So, currently in our present world, this is not so, because GoDaddy is a registrar. It just provides services to clients to register second-level domains, but they do not own, as far as I know, they do not own top-level domains. In fact,
but in this case, I can rephrase. For example, I want to make an agency. What should I do to become agency to register GTOD?
How to become
Uh,
an
agency.
We listen some bigger DNS servers, and the existing DNS provider, service provider, they can become the agency. Also, the start for any permission distributed ledger, how to from the initial network is a problem. So mostly people will negotiate between each other to set up an initial and then after the set up the initial network, the new one can be added. For example, by the agreements between the existing entities.
And do have some algorithm to show how this initial starts, and another algorithm how the decision is taken when someone gains, because it's concurrent market, and someone won. I don't want anyone new here.
And there is no specific accuracy, but the one simple one is by the principle. If there are more than half of the disease
He mentioned that the chain, I mean the entity are selected by some kind of standard or criteria. As a permission chain, their number are limited, right? There's some manually, I think there's some manual process to choose which one will be the.
We don't need to include everyone into the train.
If someone wants to go to the circle, if he needs to give a half of voices, it's an unbelievable, unapproachable task when you have hundreds of So there will be always some number after each part to start.
Okay. We can ask more questions in the open discussion session. Okay.
Yeah, because we are mainly working on the routing system, and we think the domain name is one part of the international infrastructure. So we do some research on the domain name, but honestly speaking, I'm not the domain DNS expert. Yeah, thank you.
Okay, thank you. Okay, so far Hugo is not online, so we will play his video and message to us. How we play this? We place here or here? 这样，你在这儿播这个，然后我们在那个屏幕上。这样吧，他那翻到哪儿，你再播吧。Okay, I will play his video. It's midnight for him, so maybe not easy to access. 但是声音在你那儿，声音在哪儿，你得把它给我。Okay.
Hi, good morning, everyone. My name is Hugo Salgado. I work for Yeti, the DNS. And first of all, I want to apologize for not being there in person. I want to thank Davey for this opportunity to show our work. And this presentation is about the virtual cryptography project that we're working on from 4 or 5 years, and how we envision can help to the good signing process. First, some words about the virtual crypto project. What we have is a working solution to replace a real HSM with a virtual one using virtual cryptography. By this way, what we accomplish is to provide a robust and distributed way to do DNSSEC signing. Robust in the sense of not having single point of failures, and distributed by being able to separate the signing in several pieces. All of this without having to sacrifice security. In this diagram, we see how it works in a high-level view. In this part of the diagram, from points 2 to 6, we are replacing an HSM in the normal way of the signing process. Here we have two separate objects. First, we have the signing dealer, a trust entity who orchestrates the nodes, merge their output, and verify the process. And we have several nodes which owns a piece of private data and carries the sign. Before being able to sign, we need a one-time setup of the network where we create a normal RSA key with its public and private parts, but then we generate from this n other subkeys, each one also with public and private parts that have the property of being able to generate sub-signatures that can be combined with a special algorithm to regenerate a new signature that corresponds with the original public key. So by this way, we can delete the original private key and operate only with the sub-key parts, with both the public key and the combining algorithm. So in normal operation, we start with step 1, where we have a resource record we want to design that is delivered to the same dealer. This dealer then sends this data to the end nodes in step 3. Afterwards, in step 4, each node uses its own subkeys to send the data, creating sub-signatures. In step 5, they deliver these sub-signatures to the dealer, which in step 6 first verifies each one, then waits for having a subset of n sub-signatures, and then merges them. The result then can be verified with the original public key using normal crypto operations. And then in step 7, the result is returned. After all these steps, we have a normal DNSSEC signature, which can be verified by everyone with access to the public key. We have a private API to control the process, but also we developed a PKCS11 interface, so we can expose the THXM to normal DNSSEC control software, like OpenDNSSEC, Keynote, Bind, etc. The code is open source, so you can download it from here. We also created some Docker instances to just try it, which are integrated into popular samples. But now, how can we use the virtual cryptography for DNS signing? First, a recollection on how the signing currently works. The root signing ceremonies are carried 4 times a year, each one in one of 2 physical meetings. Each one lasts 4 hours approximately and needs around 15 people, including at least 3 trust community representatives from around the world, the TCRs. This is needed because in normal asymmetrical cryptography operations, you need to have access to the private part of the key escape, which needs to be stored in a secure place. The current method hides the private part inside an HSM that needs to be accessed by n of n other HSM keys. The trust community representatives hold physical keys that are needed to unlock safes where these m of n HSM keys are stored. In this diagram, I wanted to summarize the process. At next slide, we have the minimum 3 TCRs that travel to one of the ICANN facilities with their physical keys, which combined with second physical keys held by ICANN staff people, allows to open the safe, collect the HSM keys, unlock the actual private key inside the HSM, and with the data as input, we can generate the final signature. What we propose is to distribute the signing of the data, not to distribute the key, but distribute the signing process. As I said before, after the original setup ceremony, there's no need for a private key, only special cast subkey. After that, there's no need for a physical ceremony, because everything can be carried remotely and asynchronous. Also, there are methods to verify each sub-signature to discard more than any subkeys, and to detect certain kinds of adversaries attacks. Even when the data needs to be a trusted part of the process, we can have external witnesses that can verify each part of this process. And at last, the output of the process looks like a normal signature, verifiable worldwide. So we end with a diagram like this. We don't need a globally coordinated physical ceremony, but maybe we can use local ceremonies for each part of the sub-keys time. We can use existing technologies for secure communication channels between the dealer and the nodes, like TLS tunnels and PI certificates, which can be coordinated at the same first setup ceremony. So the benefits are clear: decentralization, end of global physical meetings, and broaden the participation on the root case side. But also we know this introduces new risks that have to be identified, studied, and mitigated. And that's what we are working right now. And that's where we think the Yeti people and infrastructure can have a key part. First of all, we need to write a high-level document of this proposal, identifying all the benefits and new risks. This document should be written in such a way to be discussed with ICANN people, not only technical ones, but with policy people too. Then we're currently working in enhancing our software and to create a stress test with high number of nodes, M and N figures, and also with adversaries. At this point, we're working also in a cryptography study from the math side of the crypto to study the optimal numbers of N and N, knowing that these numbers are critical from a policy point of view. Also, we want to create a risk matrix showing the shift of risk from a single key to multiple subkeys. And of course, prepare and carry several testbeds with you. Okay, that's all. I personally feel this work should be carried on. I know this proposal can be controversial in many ways, but I think it's worth to be tried and at least be properly documented and discussed. So thank you. I will be remotely available from now to hear your comments and maybe questions. Thanks.
Okay. It's story that we can have him online right now. So we only have the piece that we do.